So this week we're going to be analyzing the PCR product that you purified. So to do this, we're going to make use of a Nanodrop, which is an instrument like a spectrophotometer that allows us to analyze the DNA. It allows us to look at the purity of the DNA as well as the concentration of the DNA. So the first thing I'm going to do is double click on the program called Nanodrop. While that's loading, I'm going to use a Kim wipe and some distilled water to just clean off the surface of the Nanodrop when we're going to be applying our DNA. Okay, the program's opened up. So I'm going to choose nucleic acid, but you can also note that there's a lot of other applications to the Nanodrop software. Okay, don't worry about previous runs. Okay, I'm reading the directions. Verification of measured wavelength needs to be done. Make sure the arm down here is down, and then I'll click OK. Once that's complete, we need to load the blink. The blink is just going to be water. So what the DNA has been dissolved in. I'm using a P20 and I'm using 2 microliters. So the water is going to go on this little stock right here, but because it has strong surface tension, I might have to push past the point of first resistance to get the water droplet off. Notice I'm also bracing my hand along the surface in order to provide some stability to the pipette. Now I close it, and a column of the liquid is going to form between the arm and the detector. Now I hit blank up here in the top left, similar to how we did with the spectrophotometer when we were looking at turbidity of bacterial solutions. It's telling me to wait. Okay, once it's complete, I'll open the arm. I can use a clean Kim wipe to wipe away the water, and then I'll collect my DNA solution. In this case, you'll be using the PCR product that you purified. Again, I brace the pipette against my hand. I add 2 microliters of the liquid I want to analyze. I close the arm, and this time on the top left, I measure. Now what's going on here is that the liquid that we add, can go ahead and save that. The liquid that we added to the Nanodrop has been subjected to different wavelengths of light. Notice on the x-axis. Such that we have all of the kind of UV spectrum shining through that sample. And what we know about DNA is that it absorbs UV light at 260. So even by looking at this graph, we can see that there's a peak at 260, which indicates that this sample has DNA in it. If you look down here, the program has used a conversion factor to convert the absorbance at 260 into a concentration reading. So we see right here that the concentration of that DNA that I added is 110 nanograms per microliter. So that will give us the concentration. The other thing that we will look at is the 260-280 ratio right here. Now this is an indication of the purity of the DNA. So perfectly pure DNA is somewhere between 1.8 and 2. So this looks beautiful. So to look at the quality of DNA, we use this ratio, which is a numerical value, but we also can analyze the quality by looking at the DNA peak, which this is beautiful DNA. We don't see any secondary peaks over here. We don't see that this peak is pushed over at 230, which might indicate some protein contamination or even RNA contamination. So everything looks perfect. We have our concentration. We know it's high quality DNA. and we can move on to our next steps of preparing this for DNA sequencing.